I'm Joel Carr. I'm a research ecologist with USGS at Eastern Ecological Science Center. So I'm just going to share some of the research we've been doing with the Refuge at Blackwater National Wildlife Refuge. In particular, I'm going to focus on one of the study sites that we have, which is a marsh migration study site. So the problem, if you don't already know, Blackwater has been experiencing ongoing marsh loss since its establishment. It's lost roughly 5,000 acres already. It's added about 3,000 due to upslope migration, but it's trying to look at the future, and it doesn't look so great, right? So they're doing what they can to try and make sure they're meeting all their multiple mission goals. Like, are they actually providing adequate habitat for wildlife, all the different species, not just salt marsh, but upland forest as well? Are they providing hunting areas, etc.? And so they're going at this as a portfolio approach, and they're trying different things, and they've been trying different things for a while. So actually just now they're finishing up a thin layer replacement at Back Garden Marsh site after a first thin layer replacement that was established in 2016 to try and sort of raise marsh elevation up, again, resist sea level rise. But back in 2014, which is what I'm going to talk about today, we tried to do a directed transgression experiment. So why money stump marsh? And what do we mean by facilitated transgression? Well, the general concept was that if you have a tree die, it alters the ecohydrology. You can have root zone collapse, which decreases the elevation of the surface. When that elevation is dropped, it's more susceptible to inundation, potential more exposure to storms, more likely saltwater intrusion, which would actually increase tree mortality. And you get this positive feedback loop, which would lead from a healthy forest all the way into sort of a ghost forest with the marsh underneath. However, the strength of this feedback could be really small, and you could have a negative feedback loop as well on top of it, where you lose a tree, and yeah, maybe you decrease elevation, but then you get reestablishment of vegetation and reestablishment of the root zone and the ecohydrology, and you basically reestablish that original elevation. So this experiment was used to try and explore this sort of feedback and the strength of these. A site was chosen very specifically. It was chosen specifically because it was actively transgressing. So Money Stump Marsh, 2007 NAPE. Here's 2009. Here's 2010 and 11. You see quite a bit of open marsh area underneath the canopy, very, very, very low canopy cover at this marsh site. More importantly, there's no frag here. That was one of the very specific site selection points that was made, was had very little frag. There were a couple small patches that got sprayed prior to the experiment. And the experiment was basically two different manipulations: a clear-cut timber harvest, a girdling to do like a slow die-off of the trees, and then a control area where we didn't do anything. We measured vegetation, inundation, light levels. There's 45 SETs out here, surface elevation tables, accretion, root decomp, ingrowth. And in 2014, they cut the trees. If you're not familiar with surface elevation tables, I'm happy to go into it. But we have numerous out there, and we also have a deep rod benchmark that's actually repeat surveyed every October to get a deep subsidence of the entire system to try and get at like that slow press driver. So again, here's 2010, here's 2014. When they did the tree harvest, they not only did a clear cut in that upper northern area, but they also took down most of the ghost forest as well, just knocked the limbs down. And you can see that with sort of the shadows. Soon thereafter, we established all our sites across these different elevation bins. You see that the girdle here, where you about halfway between the clear cut and the control is at the far west, southwest end there, southeast end, the girdle area still has a very full cover canopy. So slow die-off is occurring. Again, pretty standard vegetation surveys. The high marsh, happy distinctless patents. In the forest, you have your pine litter, because it's a loblolly pine-dominated system. Lots of pine seedlings coming up, but never really fully establishing due to light limitation and out competition. And then in the transition zone, you see the standard, the iva, the distinctless, and some other vegetation as well. The loggers, we had lots of wells out there, lots of light loggers at different elevations within the canopy to look at basically light penetration and limitations on vegetation growth. And what we found is that, roughly, 3 to 6% inundation was where which what accommodated the transition zone. And then this fed into a modeling exercise to look at impacts of the dynamics of disturbance on the system. This is a wonderful picture by Matt Kerwin from a drone. And you can see here the girdled area, the canopy is opened up. And as a precursor, you start seeing that nice dark vegetation underneath the canopy. And that is a full-on regrowth. So this is the cut area in 2015, and below it is the girdled area in 2015. You see in the cut area that there are actually tracks from the machinery that was used to clear cut the forest there and do the timber harvest. And there's some thoughts that that's impacted elevation in that system, in that area. But in general, we saw regrowth. And unfortunately, we saw reestablishment of frag in the area as well. Those have been subsequently sprayed to control it. But during the transition, one of the questions we had was, did the vegetation change intermittently? Did we have the establishment of wetland plants in this open area? Was it light limited? And by opening the canopy, were we able to get the establishment of wetland vegetation in the system? And the short answer is no, we didn't. There was some effect in the transition zone itself where we actually pushed something from mostly a wetland, likely a wetland, into more likely a wetland, but that was only in the cut area and only in that transition zone. But what about elevation impacts? Did we see those elevation impacts? We saw recovery, but did we see strong elevation signal? And we did. In the control, there was a loss. This is in the upper plots, you see basically change in elevation over time, over the period of study. And in the cut area, you see a strong decrease and then a recovery. And it's even more pronounced in the girdle area. Very, very strong signal going down and dropping in elevation. In the marsh, in the wetland areas, you have this sort of standard sea level driven accretion occurring. We can look at this slightly differently to look at the timing of the recovery. So if we look at the change in elevation in relation to the control, so we set the control elevation as 0, we can see that in the cut area, roughly about 3 years afterwards, we start gaining elevation again. So it only took the system 3 years to begin recovering. And in the girdle, it took much longer for the trees to die, a much slower loss over time. And so it took roughly 4 or 5 years before we start to see the recovery of the elevation of the system. And it's still recovering. If you look at the transition zone, those elevations are still increasing over time. But we can do breakpoint analysis, see what these rates are. And of note, when we cut the forest and when we girdled the forest, we actually saw much higher variability in the system in terms of the rates of elevation loss. And later on, we do see recovery again. But again, this recovery may not be fully there, especially in some of the areas of the cut. And the girdle transition zone, it's appearing to transgress naturally now. So potentially moving forward into a marsh system. But this leads to the question of, is root zone collapse or an elevation change of 1 to 2.5 centimeters, is it enough to induce a transition in the system? And really it comes down to this concept of like these pulse and press drivers, which Grant was talking about. And are you actually able to see whether our system is in this sort of persistent zone where you might be able to actually push the system into a marsh state or not? Or are you in this nice regenerative zone where whatever you do, it's just going to sort of grow back as a forest? And so truly understanding what those drivers are and what those thresholds are is really important if you're trying to actually facilitate a migration to occur. And so the general takeaways here are that, rapid forest recovery occurred and that this disturbance was not enough to push it into a marsh state. There was root zone collapse. It's pretty limited though. Partly it's a perched water table, but it was limited in its ability to drop elevation. But really, it comes down to truly planning ahead, knowing what the key thresholds, both elevation, inundation, salinity are, and then the timing of the disturbance to help keep that system in this marsh state, truly understanding that. And with that, I'll leave it and we can move on to the next speaker.